Hi everyone. So what did I make this week with a LCD screen, few lithium ion batteries from an old laptop and a voltage booster. This. It has a HDMI port and two USB power outlets giving out 5 volts. With one USB the screen is powered, while with the other you can charge your phone while you're traveling or even power a Raspberry Pi and convert this into a portable computer. Another advantage to this build is that if the internal battery runs out, you can continue powering this monitor using your battery pack. This is the LCD screen that I bought online. It has a HDMI port and two USB ports, one for the power and other for the capacitive touch. This is the boost converter which will power the LCD screen, and here is the charging circuit which will charge the battery. The complete material list is in the description. Please do check that for more information. Here is the schematic diagram of the circuit. The 4 batteries are connected in parallel, so the voltage will remain 3.7 volts. Each battery is of 2200 milliamps. In a parallel connection, the amps of each battery gets added up. So these batteries can deliver a total of 8800 milliamps. The charging circuit TP4056 is the main component here. It has discharge protection and overcharge protection. So the charging circuit manages the output from the batteries along with charging it. The maximum charging current is 1 amps. So to charge all the batteries it may take a while, but this IC can perform it. These two terminals connect to the battery and these two give the output. The output from TP4056 is connected to the boost converter through a switch. The boost converter can step up from 0.9 volts to 5 volts and give a stable output. From the USB, I will use a micro USB cable to connect it to the LCD screen. And yes, the LCD screen runs from just 5 volts. So this setup is enough to power up the LCD screen for a very long time. The batteries I chose need more testing. So I chose another 4 batteries. All of these had around 3.5 volts, which means that these are really healthy batteries. Because these batteries came from an old laptop, their terminals were factory soldered. I ripped them first and then give it a good filing and sanding to make the surfaces rough. Solder adheres well to rough surfaces. By clamping 2 batteries at a time, I apply some solder on the terminals first. To make parallel connections, I take a copper wire and straighten it out. Then solder all the negative sides first. For the positive side, I used insulated wire to avoid short circuit. If it was exposed wire, it may touch the sides of the battery, which are also part of the negative terminal. Lithium-ion batteries need to be handled with care as they can explode if handled incorrectly. Then I hook up my temporary circuit to check if all is working fine. Time to power up the LCD screen to see if these batteries can provide enough juice. I connected my Mac to the screen via HDMI to perform the testing, and yes, it works. By the way, have you subscribed yet? Now to make the housing, I start by cutting some acrylic sheets. I know the screen size is 5 inches, so I cut the width accordingly. To determine the depth of the box, I stack the screen on the batteries to measure. Then based on those measurements, I rip the sides from some more acrylic sheet. On one side, I have to cut an opening to fit the screen. So I take the measurements and transfer it to the acrylic. By measuring the width and height of the viewable area, I made a rectangle and this is the area that needs to be cut. I start by drilling 4 holes on the corner for the jigsaw blade. Then with a thin blade, I slowly cut along the line to make the opening for the screen. The screen fits like this. Now to construct the housing for the batteries, I set the sides in place and fix it with acrylic glue. This sets in just minutes so I can continue working. To mount the screen to the acrylic, I first mark where the holes need to be drilled. Then once the holes are drilled, I insert some nuts with spacers to attach the screen to the side. I set the top temporarily to see if it fits. For the sides which allow access to the ports, I measure them first. Here I am measuring the space required to fit a switch. Then to create the opening, I drill holes first. For bigger slots, I use Dremel tool to cut out the material. Then using the chisel, I trim off the cuts. To make the openings perfect, I used a file to bring it to correct dimension. Then attach the side using glue. I repeated this step for the other side too. Next, the circuits. I removed the SMD LEDs from the boost converter with the cutter, then soldered wires in its place. Later, I will connect 3mm LEDs to this. I did the same for both the boost converters. Now I can attach the wire to the battery before dropping it into the box. With lots of hot glue, I attach the battery to the base. I apply some more glue to the sides and between the batteries too. These batteries are not going anywhere. I connect both the boost converters in parallel so both can share the output from the battery. Then these get secured to the base with more hot glue, one after the other. I finish the circuitry by soldering the battery to the charging circuit and the output of the charging circuit to the switch. The charging circuit also gets hot glue to the base. Next are the LEDs. I fix them with hot glue and connect it to the boost converter wire that I soldered earlier. When I connect the micro USB from a mobile charger to the charging circuit, I can see the charging LED light up. And when I turn on the switch, the boost converter LEDs turn up. This means all the connections are correct. To attach this monitor to a DSLR camera, I am going to use a hot shoe. I secure the nut using Araldite 2 components epoxy. This sets quickly and is very strong. To connect the screen to the box, I drilled 4 holes. Then by setting it on the box and checking the depth of the drill bit, made a mark at the bottom by drilling slowly. Then drilled all the way through in the base. By doing it this way, I can be sure that the drill holes in the top side will match with the ones in the bottom. After countersinking, I used 2-inch screws and nut to secure the top to the bottom. By connecting a micro USB cable between one boost converter and the LCD screen, I checked if all worked well. I did not like the steel look of the screws, so I painted them black before reattaching them. So here it is, a multi-purpose monitor. Because this supports HDMI port, it can be used with any device that is available these days. The idea behind using a battery-powered screen was mainly for portability. The DSLR camera comes with its own battery. It would be a pain if I was to find a power source just for the monitor. On testing the batteries continuously, it gave me a good backup time of 5 hours and it took about 7 hours to recharge to its complete state. There are many options for the LCD screen out there. What you have to look for when you pick one is the voltage consumption and its driver. This LCD screen came with its own driver which was good enough for this project. If the voltage required by the LCD screen is more than 5 volts, then I would have rewired the battery in a different way to give that enough power. Also, a change in the voltage booster would have really helped. In the future, I will repeat this project but with a bigger screen and a brighter one. For $1,500 I got this LCD screen. For double of the cost, I am sure I will get a much better one at 7 inches. After After building the screen, I tried using this with my MacBook Pro. While I was working, I used this as a second monitor where I could watch YouTube videos, listen to songs and watch movies, and it really helped expand the screen space. If this project inspired you to make something on your own, let me know in the comments. If you enjoyed the video, please give it a thumbs up. This helps me make more videos. Follow me on Instagram to know what I'm working on right now. Here are some more videos that you can watch. Until next time, happy learning!